Okay, you should all have your worksheets handy so that you can follow along with what we're doing. I really do want you to practice graphing. You can use your calculator for some of this, and you should use your calculator to check, but although the calculator is not necessarily going to lie to you on these, it doesn't always give you a real good picture of what's going on. You also want to keep in mind, as we fill out the tables, what's going to happen with transformations of functions like we've been doing with all the other types of functions we've looked at. Shifts left-right, shifts up-down, slopishness, all of that kind of stuff. First of all, you should fill in all of the stuff up here, do all of these, and make sure you remember all of the different kinds of functions we've done so far. So pause the video, go do that, and then come back to check that you got everything right. Make sure you're looking for, that you have both the parent equation and also the name of the function. Okay, so check to be sure that you have everything correct on these. And then we're going to go look at these new types of functions. These are exponential. Note the difference here that this is not a polynomial. This isn't x to a fixed exponent. It's a fixed base, that's the 2, with a variable exponent. That's what distinguishes this from a polynomial like the quadratic one up here, that the base is the number and the variable is where the exponent is. Okay, so put in, you can use your calculators, although you really shouldn't. We know that anything to the 0 power is 1, so that's going to be 1. And then we have 2 to the first power is 2, 2 to the second power is 4. And then back here, 2 to the negative 1. Remember, that's flipping it upside down, so that's going to be 1 over 2. And then 2 to the negative 2 is 1 over 2 squared, so we end up with 1/4. 1/4. There we go. So if we scale this by ones, we have 0 going through at 1 right here, and then 1, 2, 2, 1, 2, 3, 4, and then over here, negative 1 is at 1/2, and negative 2 is at 1/4. So what do you think is going to happen if we kept going? Well, if we put in numbers down here, 2 to the third is 8. It's getting bigger, and you can see that it's getting bigger much more quickly than a parabola would get bigger. It's going to keep going up, 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 up. It's never going to go negative or come back down again. Sorry, it's not going to come back down again. As we go out on the x-axis, though, towards the negative, out in this direction, what's happening to those numbers? Well, if we're looking for negative 3, negative 4, exponents like that, you can see that because they're negative, we're going to end up with numbers smaller than 1, 1 over 8, 1 over 16, 1 over whatever. But those numbers are never going to get negative. They're just going to continue to get smaller and smaller, but still above 0. So we have a graph that looks like this. It's fairly level-ish, but getting smaller here, and then going up really rapidly. The further out you go, the bigger x gets, the bigger this gets. It's never going to give you any negative values. We're never going to get anything down here with your basic exponential graph like this. And then it's going to continue up. It's going to cross the axis here at 1, the y-axis. Domain for this is going to be all real numbers. We can put any number we want up here in the exponent. The range is always going to be the positive numbers, so we're going to end up with 0 to positive infinity. Note that this is a parenthesis. We're never actually reaching 0. We're just getting really close. And the y-intercept is at 1. Okay, go ahead and do that with 3. Do the same thing. And as you're going, think about similarities and differences. I'm going to go ahead and so pause it and then come back and check. Okay, so you should see the same basic shape of the graph. You should note in particular that the y-intercept is again at 0, 1. The domain is still all real numbers. The range is 0 to infinity. We're just going through that range more quickly up in this part of the graph, up in here. It's getting steeper more quickly, and it's also getting shallower more quickly. 1/3 is smaller than 1/2, 1/9 is smaller than 1/4, etc. So think about those, think about what all that has in common, and then let's move down to these. What's different about these is the base. Now the base here is smaller than 1, and when we do the fill in the table, we have 1/2 squared. for 2 down here, it's getting smaller, not larger. 1/2 to the first power is 1/2, 1/2 to the 0 power, 1 again. That point should be becoming clear that the y-intercept is always 0, 1, because anything to the 0 power is 1. And then over here we have 1/2, 1/4. As the x values get bigger, as we have bigger and bigger exponents, now you should be seeing that this is going to level off, versus in the other direction. Now when we have 1/2 to the negative 1 power, that flips it upside down and we end up with 2, 1/2 to the negative 2, 4. These are going back up this way. The domain is still the same. We're putting in all real numbers, negative infinity to positive infinity. The range is still 0 to positive infinity, but we're getting there differently. We're starting high up here and coming down low. Same shape, but reflected over the y-axis. Do this again for 3/4. You should be able to fill those in. I'm going to skip ahead, but you should fill in and then check on your calculator. And while you're doing that, think about how this is related to 2 to the negative 1 to the x, or 2 to the negative x. How would that graph look like this one, and what would be the same and what would be different? So go ahead and do this one, check it on your calculator, make sure that you get the same domain, same range. You should end up with, the domain is all real numbers, the range is 0 to infinity, and the y-intercept is 0, 1, and see what happens with that one. Okay, we want to talk about 5 now. You should have the graph of 2 to the x in front of you. Think about what that negative 3 is going to do to that 2 to the x graph. It's the same kind of thing that we've been talking about before. That's a change in the y. It's going to move everything down 3. So without even filling in the table, you should go back and check. But remember that the point that we used to have here at 1, that's going to go down 3, and now it's going to be 1, 2, 3 down here. We had a point at, up here, 2 to the first power was at 2. That's going to come down 2, or sorry, down 3 to here. We had 2 to the second power was 4. That's going to come down 3. Now that's going to be at 1. All of this is going to be going up like it was. And the things that were getting smaller and smaller down here are now going to get smaller and smaller down here. We're going to have a graph like that. Domain now is still all real numbers, because we can put anything in, but our range has changed. Now we're getting really, really close to negative 3 and then going up to infinity. And our y-intercept is now moved down to 0, negative 2. It's the y-intercept from before moved down 3. You should be able to do the same thing with this one, the 1/2 x plus 1, but now it's going to be moved up 1. So take your graph for the 1/2 x and move it up 1. You can check by filling in the table for this one and this one if you need to. Check the tables to be sure that you understand what you're getting. But you should also, I really hope you're thinking about this as really a transformation. Take the basic 1/2 x graph and move it up 1. Now, it looks a little strange the way I've drawn it, but it's still heading out here for 0. It just is taking longer to get there. So the range is still 0 to infinity. The domain is still all real numbers, but the y-intercept has moved up from 1 because it moved up from 1 up to 2. By now, you should also be noticing that there's a horizontal asymptote for this graph of 0. For this, or sorry, of 1. Oops, my range changed. My mistake. This should be a 1 here. Let's see if I can erase that. No. All right, so this should be a 1, not a 0, because there's a horizontal asymptote here at 1. It's never going to get below 1 because this part can never go negative. The closest it can do is get it really, really, really close to 0, and 0 plus 1, this is going to be really, really close to 1. This one had a horizontal asymptote at negative 3, which was reflected in our range right here. So you can see that what we're going to be talking about is eventually end behavior. We'll be saying things like as x goes to, and then which direction, well, positive infinity for this one, our y values are going to head for 1. In this one, it's as x goes to negative infinity, the y values are going to head for negative 3. We only have end behavior at one end. The other end is shooting off to infinity. Well, we have end behavior, but we don't have an asymptote. But we do have asymptotes at one end of the function and then not at the other end of the function as it heads off for infinity. So keeping that in mind, thinking again about transformations, this transformation changed what happened on the y-axis. This transformation here and here is going to change what happens in the x direction. X minus 1, we want to think about what would bring that back to 0. That would be 1. That's going to take our basic 3 to the x graph from before, and it's going to move all of the points to the right 1 because of that. So the thing that was at the y-intercept at 0, 1 is going to move to the right 1. The point that was 1/2 is now here, or sorry, 1/3, 1/9. All those points are coming up, and then what was 3 to the 1 was 3 is now over at 3 to the 2. And then 3 to the 3rd, or sorry, 3 squared gave us 9. Now that's going to be 3 to the 3rd that's going to give us the 9. It's the whole graph, but slid over to the right 1. Still doesn't change the domain. And in this case, it's not going to change the range either. It does change the y-intercept. The y-intercept is now what we would have gotten with 3 to the negative 1. We're now getting with 3 to the 0. Go back and try that again with this one. You should get that the whole graph moved left 1. And then on these ones down here, we're talking about slopishness. The base of the graph, the 4 in this case, the 3 in this case, will affect how steep it is, but this slopishness can also change the steepness. In particular, I want to look at this one. This is going to make everything half as high, so it'll be much shallower than it was. This one also is going to flip everything upside down. This is how if we're going to get negative numbers, this is how we get them. We take a 4 to the x, and we end up with a graph down here that does this. So I'll let you guys do that one on your own. You should still have a graph that does this, but it's going to go through the y-axis at, sorry, it's negative 2 now, because when we plug in 0, we get 4 to the 0 is 1 times negative 2, so it's going to stretch it down to here and come down like that. Everything that was positive up here is now negative down here, and steeper because of the 2 being steeper than 1. So in this case, that's going to still leave us, still never changes the domain here, and then the range is going to be negative infinity up to 0 with a y-intercept of 0, negative 2. So make sure you understand those on those pages. And then think about these discussion questions. Basic shape, how would you describe them? Base, etc., all that. We'll talk about these on Monday, but after you've thought about it, I'll come back and highlight a couple of the important ones. Okay, again, make sure you filled in all of these questions. We'll talk about them on Monday or in the next class. But in particular, I really want you to notice the asymptote and the difference in the bases. With bases greater than 1, we end up with a function which has this shape. With bases less than 1, we end up with a function that has this shape, but it still has to be a positive base. Think about what would happen, and again, we'll talk later. What would happen if we have 1 to the x? What would the graph for that look like? And what would 0 to the x look like? And what would a negative number to the x look like? You might try and graph those on your calculator, see what you get, see what the calculator gives you. Think about what should happen with those. I don't think the calculator will be a ton of help, but think about what would happen with those, and we'll talk Monday about that. Okay, these are just a couple of vocabulary things. Exponential growth, when a function gets bigger as x gets bigger. Exponential decay, when things get smaller as x gets smaller. We will do some examples of these later in the unit, But this would be things like putting money in the bank and getting interest on it. Exponential decay, this is stuff like radioactive decay, where you have less and less of it as things go on. It could also be depreciation. Things lose value over time. As time goes on, this gets smaller. Interest in the bank, things like that. As time goes on, things get bigger. Make sure you understand the vocabulary. Make sure you understand where that information comes from, what the base has to do with each one of those, and what the slopishness has to do with each one of those. And then here, this is all summarized for you in this nice chart here. And go through these and decide what you get out of each one of these. Is it growth or decay? Is it going to go up or down, left or right? We're talking about shifts in these. Is it moving left or right, up, down? Did it reflect over the x-axis? Did it go, instead of going up like this, did it go down like that? And what's the y-intercept? And here are all of your homework problems if you need them. So you should do this bookwork and make sure that the worksheet is complete and that you come in the next class ready to talk about any questions that you have.